number 23 out of 11.2. And Jameson, can you restate your question for the record?
Why does, when you find the inverse, why does the cube root go to the whole thing and not just the x?
Okay, so you've kind of looked at this and thought the inverse of this should be a cubing, right?
Right.
And subtract 2.
Right.
And the problem is you just need to get the order right. So that's really why I do that bubble thing. So we start someplace, right, an x. And then the first thing we do to it is what?
Cube root it.
Cube root it. That gets us to cube root of x, right? And then the next thing I'm going to do to that is
Add 2.
add 2. Okay, so to back out of this business, I got to go this way, right? Subtract 2.
Mm-hmm.
So if I start with a, right, I'm trying to build my formula for f inverse of x. So I'm going to start with an x. And then the first thing I'm going to do with it is I'm going to subtract 2. And now to that, I'm going to apply the opposite of the cube rooting, which is cubing. But it's to that, right? To the result of the previous step. Does that make sense?
Yeah.
This is a little bit like, did I tell you guys about the garage door example? Stars? Okay, so you want to put your car in the garage. So really crappy drawing of a car. You've had problems with the garage door in the past, right? So it's a little crumbled. And then here we have our garage door, right?
That's the problem. It's wavy. It needs to be straight so it goes up and down.
Whatever. I just need to differentiate it from the sides of the building somehow. So what are your steps to get your car in the garage? Right, when you pull up, the garage door is closed.
You need to open the garage,
Yeah, so you open the door, right? Then your next step is, so after the door is open,
pull your car.
Drive in.
Wow, it got so much bigger.
And then close the
And
door.
then close the door, right? When you want to reverse this procedure, you need to do exactly the opposite things in the opposite order, right? But you have to do them to the state that they, right, that they result in. Does that make sense? That's this thing about I have to subtract 2 first, and then to the whole thing I have to cube. That's here after I've to reverse this, right? I'm going to open, right? And now I'm going this way. Drive out. And then I'm going to close the door, right? But if I do the open, and then I don't do this closed door to the result of drive out, right? Does that make sense? I'm going to close the door either on the car, or I'm going to close the door with the car still in the garage. You guys see that? I have to do it to the result of the previous step. And what that means in mathematics is we need to throw a lot of grouping symbols in here. You guys all see that? That's part of why I do this business. It's just to kind of check myself. So like here, if I was writing down this, I'd say, okay, on this side I'm going to start with an x. Then I'm going to do x minus 2. And now x minus 2 is where I'm at. And now I need to cube that to get back. You guys see that whole thing? One thing you can do to check this is you could just throw a number in, right? So you could throw a number in here, like say, okay, I want to know where f takes 0. Where does 0 go under f?
And the explanation.
2.
Yeah, it goes to 2, right?
Yeah.
If I put 0 in for that x.
Right.
Now, f inverse should undo that, right? This should be what f inverse does. So if I have 2 proposed solutions for f inverse, right? I've got black and blue. Right? if I plug 2 in, I better get 0 out. If I plug 2 in here, I get 0 cubed is 0, right? So that one sort of checks out. But the blue one, if I plug 2 in, I get 6, so that one doesn't check out. You guys see that? That's sort of a fast and dirty check if you're not totally sure. You could just throw a number in and see if it cycles back to itself. Okay, you throw it into F first, then throw it into F inverse. If it doesn't come back to where you started, you've got a problem. Either in your arithmetic or in your idea. Does that make a little bit of sense? Okay.